the next little bit is essentially to set the stage by doing a bit of like interactive discussion of Envoy. And I should say, a sort of setting point here, my son uses Envoy, which is really kind of cool. He actually went out of his way to tell me he didn't use any of the things that I taught him in his class, but he is using Envoy. So I thought, Matt, if you could start by talking a little bit about how Envoy is used within Lyft itself, particularly like why you started building it, but also how it's currently being used within Lyft.
Sure. And hi, everyone. I'm Matt, obviously. I'm going to apologize in advance. I'm a little sick this morning. So if I'm a bit slow on the answers, that's why. So the very quick history is that Envoy was developed at Lyft in 2015. That was to help Lyft with its monolith to microservices migration. So at the time, as was very common in the mid 2010s, microservices were all the rage, and Lyft had many different microservices. And as was common at the time, and it's still common, it was very, very difficult for developers to understand what was going on. Meaning, if there were failures happening, they didn't understand where the failures were occurring. When failures were happening, it was very often to have cascading outages, either due to retry, storms, or various other things that are common within these architectures. So Envoy was developed really at the time in the beginning to help with observability. So first, understanding what was going on in these large and complicated systems. Um, and then once the observability was in place, it was to aid in a common framework for handling things in a better way, whether that be timeouts or retries or on and on and on. And in the beginning, Envoy, even though now, people like to think of it as a service mesh proxy, Envoy is very, very widely deployed as an API gateway proxy, as a middle proxy, as a sidecar proxy. It's really deployed in all of these different topologies. Um, so, originally at Lyft, Envoy was actually deployed as an API gateway, and that was again for observability reasons. And then quickly after that, we began deploying it as a sidecar in different types of situations. And then from there, once we kind of realized what that benefit was of, again, increased observability and then moving into the fault tolerance domains, it was eventually deployed across all of Lyft, and that was the original service mesh architecture. And then since Envoy has been open sourced in 2016, we've seen a similar pattern across many companies around the industry, where Envoy is sometimes adopted as an edge proxy or an API gateway first. Sometimes it's adopted as a service mesh proxy, but in many cases, Envoy becomes pervasive within an organization, again, either for observability reasons, functionality reasons, security, fault tolerance. There's just so much functionality baked in now. And at this point, much to my amazement, frankly, Envoy is now really pervasive within the industry. We see it deployed really everywhere around the world, in many, many different types of situations and in many different types of use cases. So again, it could be observability focused, security focused, fault tolerance focused. Typically, it's all of the above. And then within Lyft, again, like many other companies, Envoy is used all over the place. Edge proxy, API gateway, egress proxy. So there's really nowhere at this point that Envoy is not used. So that's the very quick summary. I'm sure you have questions. I don't want to talk for a long time about that, but
Sure.
that's the high level.
Sure. Thanks. That was a good setting. I mean, I think it's important. Um, some of the people on the call will have already known the background, but it was
Yeah.
important for people who hadn't had it. So I thought one of the interesting things from your writing was the notion that you had much higher reliability as a kind of sort of consequence of deploying Envoy. That it essentially allowed you to be able to recover from failures more rapidly, sort of operationally. Anyway, so I didn't know if you wanted to comment sort of that use case.
Yeah, sure. And within these architectures, as I'm sure most folks know on this call, is that you have you have a set of different types of failures that very typically occur, right? So in these modern architectures, you have containers coming up and down, you have network links that fail. So, failures are basically constant. And when people build microservice architectures, typically most application developers they want to focus on their business logic. They don't necessarily want to focus on all these different faults that happen. And you know, developers, they want to focus on their logic. They say, well, if I have a failure, I'm going to maybe do some retries. They don't necessarily understand all of the complexities around retry storms and circuit breakers, and again, just like the list goes on and on and on. So what we found, at least again, just to set the stage for Envoy, is that if you look more historically, as people started building service-oriented architectures, let's call it in the late 90s or in the early 2000s, one of the things that folks had going for them is that in the late 90s or the early 2000s, typically an organization was using a single language, right, or a single framework. In the early 2000s, it was typically going to be Java, maybe some C++, but if you look at a company like Amazon, it was entirely Java. If you look at Google, it was mostly C++. So the reason that's important is that because it was a single language, it was easier for them to have a single library where they could build in a bunch of this functionality, and people could include that library, and they would just get all of these things for free. They would get their retries and their timeouts and so on. If you fast forward, to the 2010s, for various reasons, whether it was actually Amazon itself, it was just simpler to build infrastructure or acquisitions or whatever, it was very common to not have your entire infrastructure be in Java, right? So you had like Python and Node, and you'd have these organizations that have 10 or more languages, and just this big expansion of their footprint. And in that situation, trying to have this very intelligent library that would do service discovery and timeouts and all the fault tolerance stuff, very difficult for an organization to maintain this library across 10 different languages and 10 different frameworks. So Envoy, again, I'll be the first to admit, and I'm sure it'll come up during this call, that the service mesh architecture or the sidecar architecture in some ways is a bit of a hack, right? I mean, you're basically trying to move in a bunch of functionality under the hood because it's too difficult to maintain it up at that application layer. So, as we move forward and trying to build in a bunch of this stuff, you find that a lot of this logic is actually very complicated. Just to get it right is very tricky. So where Envoy came in and a lot of these technologies kind of fit in is to try to provide a consistent underlayment for all of the applications that are actually working. So they get consistent timeouts, consistent retry processing, consistent circuit breaking, consistent rate limiting. And that's where we've wound up now, where we want to provide these pieces of functionality for application developers. And in some sense, I said this for years and years and years, but over time, this functionality, it just becomes lower level. It gets more built. It just gets more built into the platform. So if you look at something like AWS Lattice, it's the new VPC system where they're doing basically a service mesh built into the underlying platform. You can just see that over time, these pieces of functionality move lower and lower down. So yeah, fault tolerance has been a big part of Envoy, and I think it's a big part of our systems moving forward.
Yeah, so actually that answered one of the questions I was going to ask, which is why you thought it took so long for Envoy so AWS has started doing service-oriented architectures 15, almost 20 years ago now. And it took some time before Envoy sort of took off. And it was like the single language explanation is a pretty good one. I thought maybe you can ask two related questions. I'll start with one. So the notion of observability and control, the language you use around like the reason for why you want Envoy, um, those same words were used by the people building essentially control plane or systems for managing the underlay networks. So if you talk to the people who are designing either enterprise network management or data center network management, observability and control was the thing that they were after. And so what's I think interesting here is that we have multiple layers, both at layer 2 or layer 3, having essentially the same mechanisms in place. That is the ability to be able to transparently manage networks, be able to do processing on headers and so forth, specific protocol processing. I don't know if you have any thoughts along the lines of like why it is that we need multiple layers of this, what's essentially the same functionality built in, or is it just that we
Yeah,
could actually fix it at the net? The problem is the network isn't actually exporting the right interfaces, or maybe it's just fine and it's not really a
right.
problem for why.
You know, um, so I think in some ways it is similar. In some ways it's not. And the reason that I say that it's not is that in what some people in this group would call the network, like from the OSI model, like layer 2 and layer 3, um, increasingly over time, as is common, we have these abstraction layers, right? And in the 90s, if you look at the average computer programmer, and if you were to ask them, or someone that was doing networking or wrote networking systems, do you know what TCP is? Do you know what IP is? Do you know what these things are? Probably most people would say yes. If you talk, I think, to the average programmer today that writes services and application logic and business logic, if you ask them what is IP networking, I would actually wager that the majority will not know the answer to that. And that's not bad, right? That's because over time, like compilers and application frameworks and all of these things, we have moved up the stack. And most developers today who build systems, they focus on applications. They focus on layer 7 protocols. They want to make API calls. They want to use REST. They want to, those types of things. And we, from the infrastructure perspective, we have shielded them from the complexity of BGP and route tables and all of the stuff that now very few people actually have to understand. So on one hand, you can say it's the same, right? But on the other hand, I would argue that what Envoy brought to the table again in 2015, which now is very common, where you can actually go through and you can like look at per endpoint stats and you can get percentile latencies and all of these things. Like today it's super common. In 2015 it was not common. Like there was not an open source that did that. Nginx did not do that. So that's, I think that there's just different abstraction layers basically. And I think that we're operating at different layers of the stack.
Yeah, that opened up two more questions. So I'll just observe, actually, when I started doing networking research back in the mid 90s, a colleague, Greg Minshall, once described networking, and he was actually describing the internet as a good network is one that you don't have to think about. And that's sort of like what you're arguing here. I wanted to actually turn that around and ask the question. In some of your writing, you had said that there are certain things that you can't mask, that is, that you actually have to expose back to the programmer. Can you talk a little bit about where the abstractions break down? What are some use cases for why you're not able to just make it transparent from the application programmer's perspective?
Yeah. What's tough about this situation is that again we have these competing goals where like all along Envoy's goal, at least at Lyft, and I think in most organizations where it's deployed, is to make the network transparent to application developers. As I've said many times, application developers want to focus on business logic. They don't care about networking. They don't care about Kubernetes. They don't care about containers. They just want to, do some databases, do some caching, and they want to call some APIs. That's like fundamentally what most application developers want to do. Where it gets tricky, and where as an industry, I think we have more work to do, is you can only shield them so much And by that, I mean, let's say that you want to set reasonable timeouts. In a naive situation, you have to actually set the timeouts. You have to say, does this API a call, should it take 100 milliseconds? Should it take 2 seconds? Should it take 5 seconds? Now, long conversation, you could argue that we could learn some of these timeouts over time, and we can develop adaptive algorithms. And there's been a lot of work in this space. But I think that's where, at least historically, some of these abstractions break down, is that you can provide retry functionality and exponential backoff and all of these different pieces and circuit breakers, but they have to be set, or they have to be tuned, and they have to be learned. And at Lyft, and at most companies that I've seen that have deployed these systems, is that you can do a tremendous amount where the application developer, they just call service, and magically it does service discovery and all of these things and load balancing, and they don't have to know about that. But where it tends to break down is on retry policies, timeout policies, circuit breaker policies, those types of things, where there is abstraction leakage. And I think, again, that a lot of these things over time can be better handled with adaptive algorithms. But I still think, that actually is an area of research. So, for the researchers on this call, I would say that actually better algorithms and understandings of adaptive timeouts, admission control, all of those things, that would be a major contribution to the industry.
Sure. Yeah. So let's move. And actually, if anybody has any questions, please, put them in the chat or Zoom. So let's move a little bit into sort of forward-looking questions. One of the things that I noticed that Envoy is now sort of moving or partnering into the direction of multi-cloud, and sort of you have gateway support now. So I thought it would be really good if you could talk a little bit about, just in the general direction of where things are going, but also this notion of how do I mix on-prem versus cloud, multi-cloud settings that you're trying to do with sort of the gateway approach.
Yeah. So the first thing that I would say is that Envoy itself, from like the core proxy perspective, it's really agnostic to the runtime. Like, it doesn't care about Kubernetes or raw virtual machines or cloud or data center. It doesn't care about multi-cloud. And I think that's actually been one of the reasons that Envoy has been so popular, is this very clear separation of the data plane and the higher level control plane. So from a multi-cloud standpoint, yes, we see a lot of products on top that are trying to bridge that management control plane with the underlying data plane. But it's somewhat agnostic to Envoy itself. So I would say that Envoy is a tool, that can be used to help in these migrations, whether it be from on-prem to cloud or multi-cloud. I'll be honest, I think the number of companies that are dealing in true multi-cloud, I think that's a big buzzword. I don't think there's that many companies that are truly doing multi-cloud. I think much more common is cloud bursting or cloud migrations, where people have on-prem resources and cloud, and they're going back and forth. But again, like, Envoy is a layer that can help with a lot of the underlying tools, the security, the routing, all of those kinds of things. Um, but I wouldn't say that it's a core goal of the project to actually do multi-cloud. We're trying to have the different pieces of functionality there that can help people build these management plans.
Yeah. Okay. So another question. Oh, sorry. There was a chat question. So the question from the chat is: will C++ and memory safety be the death of Envoy?
Fun question. Look, so first, just for full transparency, I 100% of my work now is in Rust. So I'm a huge Rust fan. Um, but my general answer to this question is that, we like to argue about things on Twitter or whatever has replaced Twitter. I don't know. And, C++ and memory safety is a common argument question. I'm going to tell you the honest reality. Zero customers about this. They do not care. Like, people want a thing that works, right? and they do not care like what language it's written or any of these other things. Like they just want it to work well. So all things being equal, would Envoy be written in Rust? Sure, but it's not. And I think most customers don't care.
Yeah.
Will something come along and replace Envoy one day? Sure. Will that theme be written in a memory safe language? Sure. But as I've said before, I think ultimately Envoy in most cases is transparent to users. So when it's implemented by Amazon as part of the system, does it matter if it's Envoy or something else? No, not really.
Yeah, I should say actually, speaking as somebody who does research for a living, that actually that's absolutely true. It's like you can have some debate about some research approach, and at the end of the day, the real question is, are there any customers who will notice?
No, no one
And
cares.
usually nobody cares. Yeah, so I thought maybe we could like one last question in the direction of what do you think if you could comment on the programmability aspect, that is for people who are writing the the control plane parts of the question. So the not the application programmers, but the people who are operating application networks or operating networks. I mean, there's a lot of debate within the research community about what that language looks like or whether it's declarative or not. Anyway, if you have any thoughts on that, that would be super helpful.
It's tough. And one of the things that I've looked back on the last almost eight years now is whether we could have done a better job of having a more unified control plane. And for those that don't know, again, Envoy is a data plane component. It has a very large API, which you call XDS. That is the language that different control planes use to tell Envoy what to do. And in some sense, I think XDS is going to outlast Envoy itself. I think the API, a lot of effort has been put into what that looks like. On the control plane side, I struggle honestly to understand whether it's possible actually to have a unified control plane. And the reason that I say that is that as you get higher up in the stack, you just start having leakage, again, abstraction leakage within the organization that you're sitting around. Where do you get various resources? Where do you get different policies? Is it, pulled from GitHub? Is it pulled from YAML? Is it pulled for some other UI? And it is hard actually to find a common language that people can use to describe a bunch of these, a bunch of these higher layer primitives. And just in the interest of time, just a very quick example of that is if you look in Kubernetes, a lot of work has been done on ingress. And it's a constant struggle where ingress is basically this lowest common denominator of what like network ingress looks like. And then you have every vendor that sits there and has their annotations on top of the Kubernetes API to enable Envoy to do this or Nginx to do that, right? And then you have to ask yourself, do you really have a common API if everyone has these extensions, right? And over time, sure, I think there might be a common understanding of what, again, some of the common management concepts look like, but there's always going to be products and organizations that are trying to do things a bit differently and want these different extension points. So I just don't have a good answer. It's a constant struggle of what that looks like. The final thing that I would say is that I do believe that YAML is the death of us all. And I think that over time, customers generally, they want a more purpose-built user interface. And I think that over time, we're moving to more holistic platforms. I like to joke that we're taking 20 years to come back to Heroku, where people actually, they want a single platform that can help them with their routing and their security policies and like all of these different things. I don't have a great answer other than to say that I think that we are iterating towards a better place. And right now things are still a little bit messy in terms of various building blocks.
Super. I'm going to have to call it a stop there. I apologize. There are questions in the chat. We're going to have this panel session at the end of the end in a couple hours, so we can also do some of that there. Anyway, so let's switch to the next speaker.
Cool. Thank you.
Yeah, thanks very much.
Yeah.